Okay, so our company's vision is to transform sunlight into fuel and food for the world, and we take this very seriously. So let me show you how we're going to go about doing that.
Petroalgae is in the business of licensing a commercial microcrop system which will enable large-scale production of renewable fuels and food. The process starts by selecting microorganisms that live in the area where our customers build their plants. We pick microorganisms that are adapted to that area. We then apply our technology, which dramatically increases the productivity of the microorganism. It becomes then a microcrop. That microcrop is harvested. What's left behind after the protein is extracted is a lipid carbohydrate mash. That mash is taken to a normal petroleum refinery and refined into renewable fuels that replace today's petroleum-based diesel, gasoline, jet fuel, etc.
It's a very clean system. 98% of the water is recycled. There's no toxic waste products. And the big benefit is that the microcrops themselves absorb CO2, about twice their weight in CO2, which is a huge benefit for high-emitting industries. We can co-locate these facilities next to a coal-fired power plant or a cement factory and capture the emissions coming right out of their smokestacks.
Well, economically speaking, another element of risk reduction in our business model is the production of the protein. That protein is very high concentration and high value. So when the protein is sold into the feed or food market, it basically covers the cost of the entire operation. So that what's left over, the feedstock for fuel, is at very low cost, which means that fuel, that renewable fuel that's produced, can compete with oil at virtually any price.
Petroalgae has recognized the importance of the biology and chemistry in the growth of the algae. However, there is a very particular element is physics, the management of light, and that directly influences the growth. So we're growing more algae per square meter per day than anybody else today.
Petroalgae has the potential to be rolled out in parallel across the globe. A commercial licensee of a petroalgae system will produce approximately 1.5 million barrels of transportation fuel per year. That's enough fuel to drive a truck 1.4 billion miles.
Well, you know, I had the opportunity to work for the Department of Energy as their spokesperson for several years, and so I got to see a lot of different technologies that were out there all around the world. And this technology is a truly game-changing breakthrough technology.
The fuels that we produce are, in fact, real diesel, real gasoline, real jet fuel.
It'll revolutionize the way in which renewable fuels are used in the market today. Don't you hate seeing yourself on video? You always think to yourself, am I really that bad looking and do I sound like that? Okay, so this is essentially the bioindustry landscape as we sort of lay it out. The market need is really for a scalable, renewable energy supply, and the key to that is an economically viable biofuel feedstock, and that's without subsidies. So much of what we call macro crop industry is subsidized. That's the way that they turn a profit. Without subsidies, they couldn't be cost effective in their enterprises. So microcrops, on the other hand, have a much higher productivity, on the order of magnitude of 25 to 100% times more productive than macrocrops. So we believe that the winning answer for this biofeedstock problem is microcrops. The issue is that a lot of the industry is producing at about half the productivity necessary to be commercially viable today. What we've been able to do is double and in some cases triple that productivity, primarily through the management of light. We use precise techniques and technology to manage light in a way that makes the microcrops, whether they be algae or angiosperms or cyanobacters or diatoms, there's lots of different indigenous species out there that can be used, more productive in these systems than they would ordinarily be. We also use biology and chemistry like the other companies out there, but our proprietary light management techniques really puts us above our competitors. As I said, there's a massive global unmet need for transportation fuels. The current biofuel feedstocks, we believe, fall short. They have a high price tag, which requires subsidies. There's the food versus fuel issue, which many of you have heard about already. That's the competition of feedstocks that could be used for food, producing fuel instead. There's a supply limitation out there because these feedstocks typically have to be blended into fuels as opposed to being created into fuels. Resource problems, and then the emissions profile for some of these fuels is off. So we believe, and we've staked our business on it, that microcrops are the only economically viable answer to the biofuel feedstock problem, and that petroalgae is the only company that has achieved the productivity gains to make it cost effective. A couple things about the company. We're producing green fuel today, commercially deployment ready, truly a viable large-scale fossil fuel replacement. We're talking about a much larger segment. I'll get to that in a minute. Environmentally sustainable at a massive scale. You heard some of that in the video. We choose indigenous species, so we're not talking about genetically modified organisms that could possibly be released into a natural environment. The system itself sequesters CO2 about twice its weight. The microcrops consume about twice their weight in CO2. No toxic waste coming off the system. It's built on non-arable land, so we don't require farmland or take up farmland for these systems. The system utilizes gray water or brackish water, so we don't even have to have fresh water to grow these crops, which is a huge benefit because we're not taking away from the drinking water or irrigation supply around the world. Deployment. We're globally scalable. Our systems can be deployed in about 1 to 3 years, and each incremental acre becomes immediately productive. The way we build these systems is that it's a 5,000 hectare commercial unit. That includes 5,000 commercial scale, 1 hectare each bioreactors. And so as each of these reactors is built, they instantly come online in about 2 weeks, which means that you're producing fuel and food, which is a very important component. As our chairman said, it offsets essentially the entire cost of the operation on an immediate basis. So you're able to pay back your CapEx cost very quickly. This is sort of the process overview model. You heard some of it in the video. We use large-scale open bioreactors to grow microcrops. We then harvest them every couple of hours. They go through a screw press where we dewater them. What runs out is a liquid that's protein rich. That liquid the water is separated from the protein. It's dried, and we get about 8 to 10 metric tons per acre per year of the protein. What's left over is a carbohydrate lipid-rich mash. That mash is dried and then sent to a refinery, and through a delayed coking process, we get about 4,700 to 6,000 gallons per acre per year. The lower side is without injection of CO2. The two products that we're producing, what should be noted is that because our feedstock is uniquely calibrated, it can be dropped into an existing refinery coker. So there's no need to expand the existing infrastructure from a refinery complex. And in addition to that, we can use the same pipeline system, the same gas pumps, and it'll run in an engine the exact same as diesel, gasoline, and jet fuel does today. You can see this sort of pie chart gives you a sense of the focus of the market opportunity. And most of the industry is focused on biodiesel, which is an additive. Essentially, you're mixing in a a macro crop produced component into gasoline. However, the more important market is the petroleum-based or fossil fuel-based market, where you're replacing or dropping in a renewable fuel feedstock to produce a functionally identical type of fuel. And that's a 20 billion gallon per year market. This gives you sort of an indication of why we're more productive than our competitors. The key, again, as I said earlier, is light management. When it comes right down to it, what we've found in our several years of operation is that light management is the absolute key to being highly productive and producing highly productive crops. The license model for us is that the licensee pays the CapEx, provides the CO2, land and water, pays petroalgae a fee during construction. We receive royalties on the product annually thereafter. We have a high internal rate of return, about 25%. These systems cost several hundreds of millions of dollars to produce, but the rate of return is very high. It's a couple $100 million each and every year. We license them on a per unit basis. I said 5,000 hectares, which if you want in acres is about 12,350. The unit itself produces about 75 million gallons of biofuel each year. So about 13 of these units will put about 1 billion gallons of diesel fuel onto the market each and every year. So that gives you sort of a scale benchmark. The protein, again, is a very important part of our model that allows you essentially to produce fuel that competes at petroleum at virtually any cost. So we don't have a dollar per or a barrel price target. The protein itself offsets the cost of the system. We're currently pursuing a number of license deals. We have a healthy commercial pipeline. We did sign our first commercial license deal in April of 2009 for 10 commercial units that will be built in China. A couple of our facilities, we make use of space in the Kennedy Space Center Life Sciences Lab. That gives us the ability to do a lot of our analytical research. We also have a 20-acre facility down in Fellsmere, Florida. If you can see up in the left-hand corner there, those are two commercial scale or commercial size open pond bioreactors. Those are the first two in the world of those size. They're 1 hectare each. And as I said, they produce about 6,000 gallons of fuel per acre per year. We're the first renewable energy company to cost effectively commercialize a drop-in replacement for fossil fuel. We can get a very high yield off our microcrops by managing the light, about 2 to 3 times more productive than our competitors. We have a high-value protein product that offsets the cost of the operation. We actively clean the environment by absorbing CO2, about 50 metric tons per acre per year. Our license model, I think, gives our commercial licensee customers some certainty that they're going to be generating a profitable enterprise. Large-scale green job creation. Each of our commercial units produces about or creates about 1,200 jobs. So that's a major selling point, especially in third world countries where job creation is very important, and we're commercially deployable now. Thank you.